The sound you just heard is likely more than just the clinking of glass marbles. It is the sound of an entire childhood. Yet, few realize that creating these tiny marbles begins with millions of tons of used glass waste. Old bottles and jars are collected, sorted, and crushed into fragments before being fed into furnaces reaching temperatures of thousands of degrees to produce a stream of molten glass. From there, in mere seconds, glowing red droplets naturally form near-perfect spheres before being cooled, polished, and quality checked, all at a rate of millions of marbles per day. Today, join Mido Explained as we explore the entire process of transforming discarded glass bottles into perfect glass marbles. Although marbles are primarily viewed today as childhood toys, their history actually dates back more than 4,000 years. Archaeologists have discovered stone and clay marbles in ancient civilizations such as Egypt and Mesopotamia, indicating that humans were crafting small, spherical objects from a very early time. Centuries later, when marbles were crafted from actual marble stone, they became so popular that the word marble became the common name for the game, even though most marbles today are no longer made of stone. In 1903, American inventor Martin Frederick Christensen patented the first machine capable of automatically producing nearly perfect glass marbles. This invention paved the way for the mass production of billions of marbles, which have since become a part of childhood for generations around the world. The journey of a glass bottle begins at collection points located at supermarkets, parking lots, or recycling centers across the city. Once a bottle or jar is inserted into the machine, the system automatically scans the barcode, checks the shape, and verifies the packaging type before refunding a deposit to the user, typically 5 to 10 cents per bottle. From there, excavators or forklifts continuously load the glass onto specialized semi-trailers. Each truck can carry approximately 40,000 pounds of glass per trip. After the cargo is covered with a tarp or the container is sealed, the convoy departs the collection site to transport the glass to the recycling plant. Upon arrival at the plant, the entire batch of glass is deposited into the receiving area and loaded onto a conveyor system. Before recycling can take place, the material undergoes a rigorous cleaning process to remove any remaining impurities. Workers stationed along the conveyor line visually inspect the flow and quickly manually remove large objects. Next, the stream of glass passes beneath a powerful industrial magnet suspended over the belt. In an instant, steel bottle caps, screws, and ferrous metal fragments are pulled from the material stream and deposited into a separate collection bin. This step is crucial, as modern recycling lines are capable of processing up to 80,000 pounds of glass per hour. Once cleaned, the glass is fed into an industrial crusher. Inside, alloy steel hammers or crushing shafts continuously impact and shatter the bottles into small fragments, commonly known as cullet. Due to the significantly increased surface area, cullet melts faster than solid glass, leading to a substantial reduction in energy consumption within the furnace. In fact, increasing the proportion of cullet in the raw material mix by just 10% can reduce the energy required for melting by approximately 3%. Consequently, most modern plants aim to use the highest possible amount of recycled glass, thereby saving on production costs and lowering furnace emissions. After being crushed, millions of glass fragments move along a conveyor belt to undergo one of the most critical stages of the entire process: color sorting. High-resolution cameras and optical sensors positioned above the belt continuously scan the glass fragments at a rate of tens of thousands per minute. Upon detecting a color difference, the system triggers compressed air jets to blast each fragment onto its corresponding conveyor belt. Clear, green, and brown glass are completely separated, as even a tiny amount of colored glass contamination can alter the color of an entire batch of molten glass. Consequently, this stage typically achieves an accuracy rate of over 99%, ensuring a uniform supply of raw material before the glass enters the furnace. At this stage, the color-sorted glass fragments are discharged into separate hoppers. From there, a dosing system automatically weighs each component with precision before feeding them into a high-capacity mixer. In addition to the recycled glass, small amounts of silica sand, soda ash, and limestone are added to adjust the chemical composition, ensuring the molten glass achieves the desired clarity, hardness, and durability. Depending on the quality of the input materials, the mixture may contain between 80% and 95% recycled glass. Tens of tons of material are continuously blended until all components are uniformly distributed. Once the raw material mixture has been thoroughly blended, it is fed into a furnace. Inside, the temperature is maintained at approximately 2,700 degrees, sufficient to transform the entire mixture into a uniform, molten glass mass glowing with a brilliant reddish-orange hue. A large-scale industrial furnace can hold up to 300 tons of molten glass at a time. The process, spanning from the initial loading of raw materials to the point of complete melting, typically takes about 36 hours. During this time, silica sand, soda ash, and limestone react to form new glass, while air bubbles and microscopic impurities gradually rise to the surface and are removed. The result is a stream of glass characterized by high clarity, a uniform chemical composition, and stable viscosity. Once the glass reaches the appropriate melting temperature and viscosity, the molten stream is directed to an automated cutting system. Here, the molten glass flows continuously through shaping nozzles with precisely calculated diameters. Directly beneath, a heat-resistant alloy cutter moves continuously to segment the glass stream into droplets of nearly identical mass. The cutting speed is perfectly synchronized with the flow rate, ensuring uniform droplet size from the outset. By simply changing the nozzle diameter or adjusting the cutting speed, the facility can produce various bead sizes without needing to reconfigure the entire production line. In modern plants, this system can generate over 30,000 glass droplets per hour, with each droplet serving as the blank for a finished bead. The freshly cut glass droplets are not yet finished marbles. They immediately drop onto two precision-engineered steel tracks that rotate in opposite directions. As they roll along the tracks, each droplet spins continuously on its axis. Simultaneously, surface tension pulls the molten glass inward from all sides, naturally shaping it into a sphere without the need for a mold. The entire forming process takes less than a second, yet it yields marbles with near-perfect sphericity. Depending on the intended use, the factory can produce marbles ranging from 0.5 to 1 inch in diameter, with 0.63 inches being the most common size for toy marbles. Once formed, the still glowing red marbles roll off the steel tracks and drop onto a metal chute below. Not all marbles are transparent. For multicolored designs, patterns are created while the glass is still molten and malleable. At the shaping station, artisans introduce heated strands or rods of colored glass, known as glass canes, into the stream of flowing glass. For certain special designs, glass frit, crushed glass particles, may also be sprinkled directly onto the marble as it rolls through the shaping system. Because the colored glass layers do not fully blend with the base glass, they twist and stretch to form distinctive patterns, such as cat's eye or swirl designs. The newly formed glass beads are still glowing red and have a temperature of nearly 1,000 degrees. Instead of being cooled immediately, they roll continuously into large steel drums to cool down naturally. This cooling process typically lasts about 24 hours, allowing the internal heat of each bead to dissipate completely. Once the temperature drops to a safe level, some facilities spray or douse the beads with water to accelerate the final cooling stage while simultaneously washing away any residual glass dust from their surfaces. By this point, the beads have shifted from a glowing red to a transparent state, possessing the hard, smooth surface characteristic of finished glass. Once completely cooled, the marbles are collected from the cooling bins. Workers then visually inspect them, discarding any that are cracked, chipped, or misshapen before the remaining ones proceed to packaging. Depending on the intended use, the marbles may be packed directly into mesh bags, plastic bags, or small boxes for the retail market. For bulk orders, they are typically kept in sacks or 50-pound containers for transport to distributors or downstream processing facilities. The journey from used glass bottles to tiny, perfectly round, colorful marbles involves a series of precise steps where physics, chemistry, and mechanical engineering combine to create a toy that has defined the childhoods of many generations. Which part of this entire process surprised you the most? Share your thoughts in the comments section. If you enjoy exploring how things work inside factories, don't forget to hit like, subscribe to the channel, and turn on notifications so you don't miss future videos from Mido Explained.